everyone. Today we are talking more about mean and standard deviation, and specifically we are going to talk further in depth about how the mean and standard deviation are affected when certain data points are added or removed or adjusted in some way, and how that affects specifically the mean and standard deviation and maybe a couple other statistics as well. So for our first example, we're talking about shooting percentage for NBA players as well as teams. So we have two different dot plots here. So the following dot plots show the distributions of shooting percentage for the 30 NBA teams. That would be the one below, the one with the fewer dots, because there's fewer teams in the NBA than players, which is the one above. So which distribution has a larger standard deviation? So just by looking at these two dot plots, which distribution do you think has a larger standard deviation? The player or the team? So hopefully you said the player distribution has a larger standard deviation because the data is much more spread out. The distribution of shooting percentage for teams has a standard deviation of 1.5%. Interpret this value. So this is a review from yesterday's notes. So what does this 1.5% mean? It means typically and this is the shooting percentage for teams. So typically a team's shooting percentage performance is about 1.5% from the mean. Now it says, look at back to the distribution with players. Estimate the standard deviation of the distribution for the shooting percentage for players. Says step 1, find the mean. Okay, well now since this is a fairly symmetric distribution, the mean should be in about the center of the data set. So estimate where you think the center of the data set is. So maybe right around here. Okay, so maybe like 45 or 46. Now it says look for an interval that contains about 2/3 of the data from the mean. So from the mean, so both sides, both below it and above it. That's what we mean by the plus or minus here. So about 2/3 of the data. So for example, let's take a look. If I go out 10 from the mean, so if my mean is about, let's say 46, and I go to 36, I go to 36, and 10 from the mean this way would be like 56. Does that contain about 2/3 of the data within this interval? Well, that contains much more than 2/3 of the data. So that's too much. So I need to move closer. About 2/3 of the data. If I go right here, about 5 away, I go to 41, and then I go to about 51. Does this right here, within these, contain about 2/3 of the data? Yes. So that means our standard deviation is about 5. Okay, because if I subtract 5 from the mean and add 5 to the mean, there's about 2/3 of the data in that interval. Now, it says, if we add an additional value to the data set, summary statistics like the mean and standard deviation could be affected. Since the mean is an average of values, the new data point's position relative to the mean will tell us what will happen. So, for example, if we add a value above the mean should increase. And if we add a value below the mean should decrease. Okay, so let's think about that. So it says if we add a value above the mean will increase. If I add a value below the mean will decrease. So let's think about this. If your average in this class is an 80%, and on your next test you get an 85, which was what they were talking about in the first bullet point, what do you expect to happen to your average in the class? Well, you expect it to increase because you performed above your average. Now, if your average in this class is 80% and you get a 70% on the next test, what do you expect to happen? Well, sure, you should expect it to decrease because you performed below your average. Okay? Now, let's take a look at standard deviation. Since the standard deviation is an average of the distances from the mean, okay, so maybe I'll highlight that because I think we're still getting used to that term, standard deviation, okay? The new data point's proximity to the mean will tell us what happens to the standard deviation. So, if we add a value close to the mean, the standard deviation should decrease. Okay, if you add a value close to the mean, the standard deviation should decrease. Okay, I should highlight mean here. If we add a value far from the mean, the standard deviation will increase. Let me explain that. Okay, so remember, standard deviation is like your typical distance from the mean. So if you add an additional point close to the mean, your typical distance from the mean is going to go down because you added a data point close to the mean. It's almost like your data is getting a little bit closer together. So your standard deviation would decrease. However, if you add a data point that's far from the mean, now the spread of your data set is getting larger, so your standard deviation will increase. Okay? Now let's take a look at the next example. We're kind of continuing on still with the shooting percentage for the players. It says, suppose we added one additional player who had a shooting percentage of 35%. How would this affect the mean? Okay, so if I add that player, draw them in, 35% right here. It'd be like adding the stat right there. Okay? How will this affect the mean? Well, remember, we thought the average was around 46. So if you add a point at 35, the mean is going to decrease because we added a data point that's less than the mean. Now, what will happen to the standard deviation? Well, remember, we thought the standard deviation for this data set was 5. We answered that a little bit earlier. How far is 35 from 46? It's about 11 away. So you're adding a data point that's further from the mean. Your data is becoming more spread out, so your standard deviation is going to increase. So your standard deviation will increase because we added a data point that's further than 5 away from the mean. So suppose we added one additional player who had a shooting percentage of 47%. How would this affect the mean? How would this affect the standard deviation? So if we added them and theirs is at like 47%, so maybe like right here, okay, how is this going to affect your mean? Well, your mean is going to be right about the same. Because you're adding a data point so close to the mean. What about your standard deviation? Well, your standard deviation is going to decrease because you're adding a data point close to the mean. Therefore, your data is becoming closer together. Okay? Example 2. Use the data below regarding runs scored by the Detroit Tigers in their last 30 games of the 2019 season. First thing they want us to do is make a dot plot for the data. Okay, so first locate your minimum and your maximum. Looks like our minimum is 0 and our maximum is 12. So I'll just label this. And it says these are runs scored, so why not throw a label that says runs scored on this? Now go ahead and make a dot plot. So there's 30 games, so go ahead and plot these 30 dots according to what you have here. So 0, 5, 10. I'm using a highlighter because I think it could be a little easier. Now for part B, it says find the mean and standard deviation. Round your answers to the nearest hundredth if necessary. So go ahead, type that data into list 1 on your calculator. So go ahead and go to Stat, go over to Calc, number 1. So your mean, if we're rounding to the nearest hundredth, that's 2 decimal places. So your mean is about 3.63. And your standard deviation, which we know is the symbol S, is about 2.79. Now, the question asks, what percent of the data falls within one standard deviation of the mean? Okay, So within 1 standard deviation of the mean. So let's do the calculation and figure out what that interval would be. So it's going to be your mean plus or minus 1 standard deviation. Well, what's my mean? My mean is 3.63 plus or minus 1, so just itself, times 2.79. So I'm going to get an interval of values. In order to get my lower bound, it's going to be 3.63 minus 2.79. And in order to get my upper bound, it's going to be 3.63 plus 2.79. So my interval is going to be from 0.84 to 6.42. Okay? So 1 standard deviation of the mean, it's an interval right here. So 0.84. So does that include the points at 1? It sure does. And does that include the points at 6? Yep. Does it include 7? No, because it's 6.42, so it's about right here. So it says what percent of data falls within there? Well, I know there's 30 data points, and 5 are outside of it, so that means 25 must be inside of that range. So that's going to be 25 out of a total of 30 data points. So 25 divided by 30 gives us right around 83.3%. Now, what percent of the data falls within 2 standard deviations of the mean? Okay, so this is going to be a larger interval, so it should contain more data. So it's going to be, this time it's going to be my mean plus or minus 2 standard deviations. So my mean was 3.63 plus or minus 2 times 2.79. And I'm going to get a lower bound and upper bound to that interval again. So in order to get my lower bound, it's going to be 3.63 minus 2 times 2.79. And my upper bound, it's going to be 3.63 plus 2 times 2.79. Okay, so my interval is going to be from negative 1.95 to 9.21. So negative 1.95, that goes all the way to 0. Okay, you can't get, no matter how bad your team is in baseball offensively, you can't score negative runs, so we're going to include 0. And it goes up to, it includes any points at 9, even though there are none, but it does not include, 10 is not in that interval, so it's right here. So that includes, that is about 20 out of 30 are within that interval, which gives us 93.3%. So yes, the more standard deviations we go out, the higher percentage of the data the interval is going to include. Okay? So let's go to the last page. And it says, suppose we add 2 runs to each of the runs scored to the 30 games above. What effect does this have on the mean and the standard deviation of runs scored? Well, for the mean, we talked about this a little bit yesterday. If we add 2 runs, it's just like if we add 2 points to everyone's last test, what's going to happen to the mean? The average? Well, the average will increase by 2. And what's going to happen to the standard deviation? Well, all the data is going to shift up the number line by 2. So does the data become closer together or farther apart? Nope. So your standard deviation is going to stay the same. What effect would adding 2 runs to each of the runs scored in the 30 games above have on the range in the interquartile range? Well, let's look at the range, your old range. My old range, the smallest number was 0, the highest was 12. So it would be 12 minus 0. So my old range was 12. Now, if I added 2 to all the data points, that means my new maximum would be 14, and my new minimum would be 2. My range is still 12. Okay, so what would happen to the range? The range stays the same. And in fact, the same thing would happen to the IQR. The IQR would also stay the same. So, here's a little rule you can write out. When a constant is added or subtracted from every point in the data set, all measures of spread stay the same. So, when a constant value is added or subtracted from every point in the data set, all measures of spread stay the same. Now, what are our measures of spread? What statistics do we know that are measures of spread? Standard deviation, IQR, and range. So just a reminder about outliers. Excluding an outlier can affect the standard deviation. Because remember, back in chapter 4, we learned that it also has a drastic effect on the mean and the range. So, are there any outliers in the above data set with the tigers? Hint, Q1 is 2 and Q3 is 5. Well, let's check. Remember, you're checking both directions, your lower and your upper. Just a friendly reminder, outliers in the lower direction are less than Q1 minus 1.5 times the IQR. And outliers in the upper direction are greater than Q3 plus 1.5 times IQR. So my IQR is Q3 minus Q1, so it's 5 minus 2, so my IQR is 3. So outliers in the lower direction would have to be less than negative 2.5. Well, remember, the lowest run scored you can have in a baseball game is 0, and that's what they had, so there's no outliers in the lower direction. Outliers in the upper direction would need to be greater than 5 plus 1.5 times 3. So that would be greater than 9.5. So let's take a look back. Remember, greater than 9.5. Yep, there was a value at 10 and a value at 12 that were both greater than 9.5. So there's two outliers in the upper direction, one at 10 and one at 12. So how would removing 12, which was an outlier from the data, affect the following summary statistics? Well, let's see. If you take away the Tigers' best offensive game, which was 12, what's going to happen to their range? Well, they're going to have a new maximum if you take away 12. It's going to be 10 now. So what's going to happen? Or I'm sorry, what's going to happen to their mean? So if you take away their best offensive game, if I take away your best test score, what's going to happen to your overall average? Well, it's going to go down. Now your range, you're going to have a new maximum. Your maximum isn't going to be 12 anymore. The Tigers' maximum is going to be 10. So your range, your data is now closer together. So your range is going to go down. Well, you removed an outlier from the data set, so your data is less spread out, meaning your standard deviation is also going to go down. Try the next one on your own. You can pause the video. So now, even though it's not an outlier, how would removing both of the zeros, so their worst offensive performance, affect the following statistics? Well, if I take away your two lowest quiz and test scores, what's going to happen to your mean? Well, it's certainly going to go up. What's going to happen to your range? So now your minimum is no longer 0. Your minimum is going to be 1. So your data became closer together, right? Because your data now goes from here to here rather than from here to here. So your data is closer together, which means your range will go down and your standard deviation will also go down. Okay? Make sure you keep your notes next to you while you're working on your homework. Good luck, guys.